This is I'm Keith Handy. This is Jesse Chappell. That's Randy. We made a ContinuuCon 1 and 2. Finally, we have overlap edges. Radio musical instruments.
Have you learned from Rob?
From what?
From Rob Schwimmer. That's how he is in the morning.
This what? Yes. Poll, everybody. Shout out a number. How many hours of sleep did you get last night?
5.
7. 6.
5.
4.5.
What about the night before?
6.
7.
8.
Not hearing a lot of 2s and 3s. Okay. Well,
Are you a
How many
2
did you
or
get?
3?
huh?
Are you a 2?
No, actually, last night I got probably a full, what would be considered a full night of sleep. I just haven't made the sleep that coverage for the previous 6 nights.
Well,
So.
we knew you were going to get up here, and we wanted to get enough sleep to be really.
Yeah. So these Dunkin' Donuts coffees are very small. It's like I don't think that counts as a coffee. So where we last left off, I'm sure you all remember yesterday.
There are some new people here, so maybe it's
We demonstrated. Do you have pictures that you could show of the things that we just, like the TumDrum and stuff, just to refresh for people who don't remember the TumDrum? These were
here's a piece of parts
some
of it.
photo. Yeah. So we looked at these guys, and it was amazing.
I didn't have the full one because
Yeah. Okay.
Yeah.
And everybody fell in love with that instrument, and
Yeah. Well, and then last night you had the whole drum kit on the one.
yeah.
That was
on the little one.
astonishing. Yeah.
and so we're gonna pretend that Jesse never actually did presentations at ContinuuCon before. This was his first
Forget
one.
about this old one.
Hey, it took me 37 years to make
It
something
did.
people are interested in.
It
so,
did.
You know,
It did. So I'm a.
gotta stick with it.
This is my turn now. And Randy demonstrated MIDI Merlin. Nice job, Randy. Nice job, Randy. Nice job, Randy. And now it's unfortunately my turn. So I had 2 main parts of what I was going to do, which one was going to be to show what I'm working on and where I'm at with it. And then the other part was just going to kind of talk about the experience of learning to do this stuff and what it's been like over the past few years. Not even that long, a year and a half even. So I will start with eeny, meeny, miny, mo. We'll start with the thing. I'll try to be as non-reedy as possible. Basically, I wanted to make a sort of keyboard where each key would be a continuous Z control for its own note based on range of travel. It would mainly be for my own use, my own interest in having some left-handed thing that I could just, I'm not left-handed, I mean like that if I was doing some cool glissando-y thing with the right hand and just be able to hold down some chords and get them in tune right away and do like a 7th chords and sharp 9ths and whatever. And you can't jump onto a non-rounded continuum and pop out a sharp 9th chord and have it sound like you did that on purpose. So just to be able to do that kind of thing but still have dynamic control, and eventually would want to implement some degree of dumbing down to where I can do LFO-ish kind of things but have them function in a way that's not as across the board linear as what like a synthesizer does, where you have a pitch LFO that goes in a sine wave and all the keys modulate at the same time in the same rate and same amount. You know, you want that like maybe more fluctuation in the higher notes and less in the lower notes and slightly different speeds between them, so it sounds a little bit more like a section, like an instrumental section. Before I can get onto that cool creative stuff, I need to address some critical technical problems with the thing that I'm working on, which is not the board itself. This is just the form that I decided to throw it up together for the event, but the individual button itself is the thing that I've been trying to work on and trying to sort out.
Is that about an inch of travel you have? on
No. Right now, this is actually less than what I was trying to make it do because the sensors that I made were having problems at the extreme, so temporarily I reduced it down. I was trying to get approximate travel of like a piano key. And I actually had this gentleman tell me, no, you're not going to want that. When you're playing like the Continuum or something, you're only really have a motion of what?
5 millimeters.
Yeah, at the most 5 millimeters. I measured like my synthesizers and my piano and my Hammond organ, and the organ was different. The organ is a smaller travel than the other ones. So it's like 8 millimeters instead
the
of
faster play.
yeah, and also like you can do this stuff on the organ, and you can't do that as well on a
Right.
travel of
No concern for catching velocity value.
right. Although it's funny on the organ how you can hear if you do move it down slowly, you can hear multiple switches activating.
Pretty.
Not all the not all the overtones are firing off exactly at the same time. I feel. And I was gonna say, as of about a month and a half ago, I figured out a bunch of things that I need to do differently on this. But the ContinuuCon was coming up, and I had already agreed to be part of the presentation with Randy and Jesse, and so the commitment was made to follow through and try to make a complete thing with what I had as I had it, and that's this, Okay.
Did it take a long time to tune the resistance so that you felt really good about it?
I haven't done that much work on the resistance itself, because that is just a function of the spring. And we had a lot of conversations about, when I was talking with them, about what kind of springs to use, what size, what would you call it, the gauge or thickness of the wire itself that coils around.
So I gave him a suggestion and he just got something else.
And
Well, opposite day.
this is, that's our relationship in a nutshell right there.
It looks like that's a key part, that's a unique and key part of this invention.
Is
that
amount of that resistance?
how it feels, and what you can do with it.
Yeah, I'm kind of wanting to go more with go a little bit lighter. I want to be able to play more notes. Is the thing. The individual notes. I do like how it feels for everyone. But as soon as I get into like 4 notes, then I'm doing a workout.
Right.
And see, some of these, like a problem that I have here is, you see, like actually when I get down to the bottom, it's up there and then it loses it a little. Some of them. I'll talk a little bit about what the idea was behind it and how I'm going to work to try to have it more reliable.
I'd just say one thing about that resistance. If you try to match what a trumpet valve feels like, it's got this nice, you're going for a fairly substantial range of motion, more than a Continuum. And those valves, they're very, they're whatever they're using in there, they're very, very responsive and they very, very fast.
Yeah.
It's grease and spring.
Yeah.
I think in there.
Yeah.
Yeah, there's a PTFE oil. If you email me, there's one that's commonly available, which is really fantastic.
Now, does that oil, that's metal against metal in the trumpet. If you were using different materials, like say plastic, 3D printed plastic or nylon,
I don't think you'll have trouble.
it'll work with that too.
Yeah, and it's very nice stuff. If you look at it under a microscope, you can scrape it, and it likes to cover one molecule thick layer. So and it lasts forever. I've looked at Continuums from 5 years ago, and it's still perfect.
All right, because I'll ask, because trying to reduce friction was one of the things I wish I had one that I could take apart that had the inner thing in it. What it's actually got is little wheels on all sides of it. Do you have a picture of them? Yeah, so the inner thing right now, I've got these little rollers. And on one side, there's one roller that faces the board. There's a little circuit board, and with a strip of velostat. I'll talk about that more in a second. And then it's like a triangle shape, like a equilateral triangle. If you're looking down from the top, with wheels on the other two sides to keep it. And that was my solution at that time for. I don't know if that's staying or not. I don't know if I'm gonna just find something that can slide. That might be, if I can do that and still have the pressure thing in the same place. But the thing here, I think that it's a little bit different than what I'm aware of in terms of, and I need to ask you, by the way, about, I understand, whoa, no, you, no, because I heard you saying that the instrument uses force sensitive resistors.
Yes.
What, me asking you guys a bunch of questions should probably not be a thing that I do much in my time.
Hey, you got the chance, go
Yeah,
for it.
so now that you're all here, now that I've brought you into this meeting to
Solve your problem.
Yeah, to brainstorm everything out for me. So what I did early on was I bought some commercially available force sensitive resistors. They cost like $6 a piece.
Yeah.
And they're like there's a little round part on the one end that's the resistor, and then it goes down a long area, and then there's two contacts at the end.
Yeah, it looks sort of like a sperm.
Yes.
Yeah.
And those were a pain in the ass. It's this thin plastic stuff, so that if you have to solder it multiple times, the plastic will start to melt. And I tried to make these little boards where each key would just directly go down onto. Do we have a picture of one of those?
Well, one thing, the Eaganmatrix, right?
Yeah.
Well, John Lambert, when he was designing that, the heart of it is the Eigen key, that he calls it. And what he has an LED and a light-dependent resistor.
I thought about doing some of that stuff too. Yeah.
And then he has a piece of plastic with a gradient of opacity, and it just slides down, and that way you get no pressure at all.
Yeah.
And his keys, you just about blow on them, and they'll actuate.
Yeah. At some point, I'll experiment with that too.
I mean, it seems like it feels great. I think
Yeah.
you've done it right.
It's amazing to watch you play it, because you're experiencing all these 100 positions of, right? The resolutions seem really nice to sink into.
Well, and individual FSRs are a pain in the butt, because we use them in Jambé.
Yeah.
And the dirty secret in the musical instrument business is when you make enough of them, they screen print them in whatever format you want.
Oh, okay.
And so then you aren't having to solder.
Is the material in the force sensitive resistor, is that the same material as when you buy a sheet of velostat? Do you know?
No, it's actually it's printed ink. If you look under a microscope, FSRs have a bumpy texture, and so if you have two layers of FSR touching together under light pressure, just a few bumps touch, and the more they press against, a lot of bumps touch.
Okay.
And that's basically how it works.
Because
it's a carbon material.
These are using strips of little pieces of velostat from a sheet of velostat,
Piece of resistance.
which I learned about from a guy at the Makerspace.
Yeah, that should be.
And so these are the or that's one iteration of the little.
So what
sensing
contacts the
strips on there.
velostat?
Pardon?
What contacts to the velostat to make the circuit? Is it like a little wire or something?
The velostat sits pressed up against the open part of that circuit board.
But you must have some sort of a contact that's pressing against it to get the electrical
The
connection.
roller?
It's the
Is it
wheel.
roller?
But
So-
that roller looks like a piece of plastic.
No, it's first of all there's the board, and the velostat is taped onto the board, and then there's a little piece of foam over the top of that kind of keeps.
Oh, so that is pressing one
And then-
position on the velostat against the board.
Yeah, that's what, if you all would just listen and let me finish my story. No, what I was gonna,
Sorry.
no, this is, so I'm, you know what, I'm actually was really glad that my thing got moved to the second day, because like, after we've all jammed together and drank wine together, I don't have that, like,
You can manhandle us.
Yeah, yeah. So, the initial idea was the force sensitive resistors laying down flat and having a key over the top of the force sensitive resistor and pushing down on it. And I was, and I had it's not on the screen. And so I like designed this cute little 1 octave board where there'd be these things that would be on top of where the resistor was and pressed down on that. And ran a bunch of tests of how they, how it fluctuated on the screen and stuff. And it's my impression before I didn't even try to do anything musical with it. I just looked at it on graphs, and it just seemed so nonlinear that it was unusable. Like he was encouraging me to just apply appropriate math to it to correct for it, and
so from what
I felt like this is too. Like the amount of the extent to which I have to use corrective math on this.
So you're saying from one FSR to another, the pressure.
Well,
response.
between one, that's one, but also the range of as you push down on the thing, unless you have your thing perfectly designed, I guess what you would do, I need to know what's inside your.
Even for the linear resistors, which are simpler than these, that are in the Mini, I do a third order calibration on every one of them, and they're off by a fifth.
Yeah.
And in fact, I think one of the reasons you don't see ribbon controllers is because people don't calibrate each one. In your case, it's much worse because I only got 1 ribbon in there.
Yeah.
Right. You got too many.
Right.
You made the right decision.
So I was not liking what was coming out of that thing, and I felt like I needed to take a big giant step back and stop thinking about a keyboard, stop thinking about the overall thing, and start thinking about the part. And so I have this sort of dream of I want to have a push button that acts like a potentiometer. That it has 3 leads on it. It's a voltage divider, and I played with. I had this kind of moment. I guess I don't need to draw it. I can just describe it. Where I took. Well, first I made a little meter for myself. I just took an Arduino and some LEDs and made a little input meter just so that I could experiment with it and test it and just see it and have like I just. Yeah, is that a video or is that just a picture?
It's a video. Yeah.
Okay. I guess you can go ahead and just like made me feel like okay, there's a potential here. Is I so I wanted this sort of voltage divider kind of functioning, and so I took 3 strips of copper tape and just put them out in parallel on a piece of cardboard, and put a sheet of Velostat over the top of that, taped it down with I think probably just regular electrical tape, and connected those 3 to the input and put a piece of, I don't know if I put the piece of foam down immediately or I think I didn't immediately put the piece of foam down, but I put my finger down on the spot of the middle strip of copper tape and then rocked it back and forth between the 2 gaps, the gap between strip 1 and 2 and strip 2 and 3. And I really liked the responsiveness of that, and I really liked the smoothness of that. So I was thinking, turn that up 90 degrees and have that happen inside a little device that I could just, and then if I can make them and have them be consistent, I can arrange them in any pattern. It could be arranged like a keyboard arrangement, or it could be one of those hexagonal keyboard. I don't know what those are called. The
Hex keyboards.
Hex keyboards?
Yeah.
Okay. Or another one I thought of was like arrange them like guitar fret arrangements, so that it's like six rows of them.
Like an accordion.
Yeah. I mean, I don't know I don't know how accordion buttons are arranged, but.
Well, it's a hex keyboard. A hex keyboard is a grid wherein each row is offset by a half column and squished down to make hex.
Right, I've watched videos and I know how it's like anywhere you move, you're just transposing the same pattern into it. So those are cool, and I'd love to play with those.
But it's a matrix.
Yeah. And maybe I had 1 or 2 other ideas. Oh, maybe like having an actual like a circle of fifths chord generator kind of thing, where you have minor chords on the inner ring and major chords on the outer ring, and then like related chords like dominant chords and stuff kind of connected to them in some pattern, and then you could just create chord sequences by just moving different amounts of direction, or moving two nearer ones would make pretty and consonant kind of chord changes, or moving to a farther one would make a more dramatic movie score type chord change. So, where did I leave off of that? So I guess you can see that basically what I did was I transferred that little experiment thing into the inside of these circuit boards, which are all separate. And that is, although that gives me modularity, that I can assemble them in any arrangement, it also brings up a problem, which is that I have to get each of them in there and have each one in the right position, and have them fit snugly. And so I'm thinking my next iteration, I'll make a wider circuit board that covers a whole range of everything and has all the necessary contacts on it, and then the keys, the mechanical parts will be assembled to it on both sides.
So in this one here, are you saying that internally you've got a piece of copper tape, and
there's no copper tape, it's on the circuit board. So do you have this is not the exact pattern that's on the circuit board now, excuse me, but it's actually a simpler one right now where there's a contact and a contact and a contact, and I just have the solder mask open on that spot so that they're exposed. And the Veltstat, the little strip of Veltstat sits on there, a little piece of tape goes over that.
so that what looks like white right now is just reflective of light. That's like
That's copper.
Yeah, that's.
Okay, circuit board copper.
Yes.
Okay.
It's
Great. And it seems to work just fine.
Yeah, some of the unpredictability issues that I'm having, one thing that I think is that, and I've seen it with some of them, especially because it's a thin area and a thin strip of tape, and it's not adhered along the sides of the strip, it's only adhered at the top and the bottom of it. So if it's not completely tight and snug, then rolling the ball down it could cause it to slightly pull away from the board. So I just recently, seriously within the past week, learned about Z-conductive tape, where you can adhere something directly flat onto something, and the conductivity only goes through this way and not any other direction. So I feel like that solves the problem.
You say copper, you're talking about normal
That's
circuit board trace material.
yes, that's circuit board traces.
Which is usually something called ENIG, because copper alone will tarnish.
Right.
After.
Okay,
Yeah.
okay.
I think this is them having finished it with the. Is it, what color is it?
Yeah, they do a.
That doesn't.
It's a gold color.
Yeah,
It has
yeah,
a little bit
it's
of gold in it.
yeah. It's just
Pictures,
this is not a
right.
great photograph. That's
But the main point is that this will work great because you won't tarnish.
Yeah.
This will stay looking
yeah,
good.
yeah. Again, Jesse had showed his circuit boards that he used for his TumDrum yesterday. Used the same company and the same design application, the Easy EDA for designing the circuit board, and JLC PCB for making the boards. And I've been happy with what I've gotten from them so far. And by the way, they have is it like a 20-minute video of their factory of somebody going through and just showing them every part of their factory. If you look for it, it's super fascinating, yeah.
How do you attach the Veltstat?
Just a piece of tape. Well, right now, it's just a piece of one-sided tape that goes over the Veltstat and holds it down.
Okay.
And that's why there's not as good between, say, this is the circuit board and this is the Veltstat. There's potential for this happening, and that's
So they might bunch up or something.
right. I mean, it's not doing it a lot because it's attached here and it's attached here, but it's, and these can be wider. I mean, they don't have to be, right now they're a 1/4 inch wide, and I thought I needed to do that, but they could actually, if I do want to do these as independent pieces, they're going to have a wider board in them.
What I can tell you is you're welcome to email me later on, and I can help you as the thing evolves.
That's awesome. That's awesome.
For $5.
$5 a what? $5 a minute?
No, anybody else, if they're making something like this, they need some help, I'm happy to help
Yeah.
out. By the way, next week, or at the end of June, I'm teaching an instrument making class at Karma, if anybody's interested. It's a 1 week workshop. Me and Sasha Lightman, who just taught.
Oh, I
this.
saw.
Yeah.
Yeah, Sasha. I saw somebody actually sent me a link to that.
Yeah, it should be fun.
It was like, this seems like a thing that's up your alley, and I looked at it. I'm like, yeah, it also seems like a thing I'm not going to be able to make it to, but yeah, but yeah, definitely.
Are you happy with the spacing you were talking about?
Between the keys?
Yeah. Does it feel right?
I actually, for this arrangement, and like I said, this is just one of many possible arrangements. I ended up just going with keyboard arrangement for this event because it would be the least of a headache to put together.
Is that the same spacing though as white keys and black keys on the piano?
Yeah, as a full-size piano. Like, I measured the distance between and then divided it down, and so the white keys are all the same distance apart that the white keys would be on a piano, and then the black keys are just, instead of being exactly where the black keys would be, they're just offset in exact spaces between there. So.
But it doesn't feel bunchy or crowded when you
No, if
like
anything,
you like a lot of notes and chords. And
if anything, well, it's hard. It's definitely hard to incorporate your thumb into a, you know.
That's what happens when you don't have a lever length.
Yeah,
you know,
yeah.
Because your hand is not on a single plane.
Yeah. Yeah.
And it's a similar issue for all the hex keyboards.
Yeah. Yeah. But that's, you know, the size and distance between them is just kind of a last minute thing that I'm, you know, like I said, this is not the thing I'm discussing. This is the thing, you know. So if I can get this right, then I can do this and a whole bunch of other things.
Yeah.
If it helps, in this print, what I did is they're 19 millimeters apart, center, or 3/4 inches. And that happens to be the same spacing on a standard ASCII keyboard. And because it's the average spacing of fingers. And people generally don't, it's always a compromise between how much for each note and then how much you want to be able to stretch in a chord.
Right.
And it seems to be, people like it, but you know, it's hard to say.
Yeah.
I think it's different for everybody. If you got big, podgy fingers, it's going to be different. You know?
Yeah.
Did you set up to do what it seems really great at, which is the caressing of a sound?
That's what I want.
You did not. You also want it to be staccato drum thing.
No, I'm not really interested in making it for that because I want it to be used for the things that a keyboard is not meant for.
Yeah. No, it seems like that's so smart, and it looked great for that.
Like for my own purposes, you know, and I use a lot of like sample libraries and stuff like that to do, you know, say I want a string bed or a choir or some kind of pad or something going on. It's just, the way a keyboard works doesn't do it because the initial attack has nothing to do, there's no relation, you know, if you got like a choir sample or something, what the hell is key velocity have to do with that? You know what I mean? It's nothing to do with the, you know.
Do you have any patches mapped to like poly filter or something that you could play?
Oh, I'm sorry.
You know, where this finger goes down, it's a little brighter, but this finger's not down as far. And it's
try the funny boy.
Dark.
Which one was that in? Feel free to like other people can.
Also, do you want to talk about anything else about our stuff? Like this is a great time
to do the
the
overall stuff. So yeah, I pretty much covered everything that was on here.
This still works for percussion.
Yeah, but it's kind of like unnecessary for percussion.
Yeah. All right, go ahead.
I think that the sort of like philosophical stuff that I was going to talk about, or just like the kind of personal angle of what this experience has been like, I think that can morph into just us talking as a group about our experiences, with figuring all these things out, or we had a couple of points that, you know, since we've been the three of us have been video conferencing and messenger chatting since I don't know if it was since the first ContinuuCon, or we weren't really doing.
Yeah, not for basically the last year and a half.
Yeah, and I just want to like stress how important that has been.
Keith, can I ask you a
yeah.
question? Did you ever try hooking up an X-Key 37 to? So what you can do with the Continuum with the Eaganmatrix is the X-Key has polyphonic aftertouch. And so it goes out on channel.
Is that the thing? Is it kind of
it's
flat?
very flat.
Yeah,
It's like
it's
as
yeah.
if Apple made it.
Yeah.
Yeah,
it looks
they're
like
very
an
nice.
iPhone.
They're very portable.
Yeah.
They're nice enough for what
Yeah.
it is. You know?
Yeah.
But what it does is it has polyphonic aftertouch. So the way the Continuum works with that is that we look at the polyphonic aftertouch and then treat that as separate things, so you can actually play an X key, get the keyboard experience, and then play an external thing. We have a mode in the Eaganmatrix where it'll identify where the source of the MIDI information came from, and you can program accordingly to it. So it sounds like a really ideal solution to what you're trying to do, except the aftertouch sucks. It's just, I mean, it sucks in the sense that it's as good as what you could expect, but you just don't, it's not consistent, it's latent. So, you know, this thing
To be fair though, he told me it was the best aftertouch he'd seen.
Yes, well that's because
But
not many people
it
do
sucks.
it polyphonic.
So that's, yeah. So,
It's the best, but it sucks. Yeah, you know what? You know what? I kind of always hated aftertouch in general.
But what they're you can set the X key into this mode where it's ignoring, it's using the initial key velocity to say that's where the aftertouch jumps to.
Yeah.
And there's all these parameters. It doesn't matter how you monkey with them. You'll never get it as good as what I just felt right there.
But
You know,
the beauty of the X key is, well, first of all, it's only like $150 is what they're doing.
Yeah.
But the key doesn't move. I mean, it's
Yeah.
you're
It's a
just
scissor
basically
key.
having pressure on a stationary key.
Yeah.
So you don't have the problem of normal aftertouch
Right.
like you get in keyboards, where it only happens after you press the note, which is stupid because the note's already there. You know.
Yeah, I've kind of gone back and forth in terms of whether I even want travel or not. I mean, I've been figuring out as I go along what it is I'm really wanting to accomplish, but because I initially started playing with some things that weren't going to really have much travel, and then it's really funny when you show what you're working on to people early on. I should throw some people under the bus here. Yeah, do it. No, they're anonymous people, but just I joined a makerspace on November of the year before last, a local makerspace in Rochester. It's a really nice one. They've got lots of 3D printers, laser cutting and metal work room in a woodworking shop, and a whole electronics workbench and you know, an Arduino and microcontroller area, and a good community around it. And they had started up about 4 years before I joined, so they're probably coming into like year 6 of being there. So it's still relatively recent thing, but but that's been a really positive. That's been one of the very positive things in my life in the past couple of years. And by the way, the existence of this is one of those things too. So pat yourselves on the back.
Thank you, Sally.
Yeah.
And just that accessibility to 3D printing.
Yeah.
To be able to prototype like that, that's crazy.
Yeah.
It's just,
And that's been these guys. They're being very quiet right now. I'm trying to encourage them to
Yeah, Randy.
participate a little
So
bit.
yeah, this is a very important team to form, and I think everyone should consider having a sounding board, resource pool, just thinking outside of your own box for a moment. Just listen to others, because you may think you have the right answer about a certain problem, and there's a better one just 2 minutes away, you know, after you call over Skype or something.
Yeah.
Yeah, I mean, you know, Randy bought a 3D printer, so he didn't have to go to the library and you know,
Same
spend 3 hours. printing this tiny
situation.
little
I went
thing.
to a makerspace, but it was at a public library, free for the city I live in. But I was going there so often, and they have a 2-hour limit for
Oh, are we?
prints.
We're being, all right.
I would say just keep going, right, if you don't mind.
We'll just transition into Randy's next, right? Or-
Well, the thing is, Gary, that, yeah, we still have Randy's,
Yeah,
thing to,
exactly.
you know.
I felt like I wasn't using, like I was trying to say as much as possible to try to fill the time, so, yeah,
All right.
let's kind of wind it down, I guess.
All right. So-
Anyway, yeah, so
But that's a good message, I
Yeah,
think,
you can
about
keep- you can keep your-
the
finish
group.
your talk.
I mean,
Yeah.
that's-
Oh,
that's
yeah.
Yeah, that's
value.
basically
So-
what happened is a 2-hour print time limit for each person per day. You can only print so much. But I wanted to print this really complicated ring controller design. Some of you saw it yesterday. I'll be taking it out again in a while. There it is. So whoever wasn't here yesterday, it's a wireless Bluetooth connected ring controller. The microcontroller is worn on the wrist, and it's two rings. One's a momentary switch ring, and the other's a continuous control motion sensing ring. But that's what I went to the library to print. I was able to print the ring. It's the push button ring, and that was kind of before I got into the microcontroller, the Arduino programming and stuff. But I already knew I wanted a ring that fits perfectly my own finger ring size, and I want the buttons to be on the inside. This is also like I have prototypes of other controller devices, hand worn, like glove controllers.
So you basically had enough of going to the library.
Yeah, had enough, and I bought my own 3D printer. It was the cheapest one you can find for the highest quality, Chinese-made printer, and this is while we're all communicating still. And Des is like, okay, you can be the guinea pig, and I got it. This is I got it for my birthday, I guess, in that year, whatever year that was. And since then, it's been upgraded. So cheaper printers you can upgrade with custom parts and get even higher quality, but you have to have patience and you have to know what you're looking at. And
$200.
yeah, $200.
Wow.
That doesn't. You can't do that. You couldn't do that 5 years ago,
Right.
or even 3 years ago, probably.
Not at that price.
Not at that price. So this is where we are right now. The accessibility of technology tools, libraries of code that exist on the internet. If you want to make something, you can do it like right now. That's the message to the world.
Which modeler do you use?
So there's modeling, and there's another step which is called slicing for manufacturing. You know, you're aware of. But I have been using this non-mechanical, manufacturing modeling software called SketchUp. SketchUp. Right. I've been using that since 2004 when there's a small company in Colorado called Atlas.
Yeah.
And it got acquired by Google, and then it got bought by another company, Trimble.
Oh, Google no longer has it?
No, Google doesn't own.
So they still keep the free version?
The old versions still exist on the internet, but Trimble offers a free version.
Okay, so they maintain the free version.
There's it's called SketchUp Make. They update every year.
What's it called?
Make. The version is called Make.
Oh, Make.
SketchUp Make, yeah. And then there's a SketchUp Pro.
Yeah.
But when it came time to do mechanical, like manufactured parts, there's some limitations, and there are STL exporters, and you can manage. I just happen to be good at using SketchUp because I'm using it so long.
Yeah.
But when it came time to like build stuff with like exact measurements that you can insert tolerances, you define your dimensions with your nominal dimensions first, and then through parameters, which I didn't even know about until Keith enlightened the both of us.
And that was one of the great things about the makerspace, was that they had a rich community of instructors that it's all part of your cost there, that you can sign up for any of the classes that they have and learn the 3D CAD software that they teach. Is Fusion 360.
So Fusion 360 is what I was using for a little while, and that's what
I use, and that's what Keith uses.
He's used, yes. And so when I need to make something simple, I do it in SketchUp because I can do it a lot faster.
And I think Fusion 360 has a free version.
That's-
the water.
Yeah,
one.
that's what we're using,
Yep.
yeah.
It's free for non-commercial use.
Yeah.
So that's basically what you find at makerspaces. And anyways, the message is,
This is a great time to do
Great
this kind
time,
of stuff.
yeah.
Build your own stuff, and the two ends of that would be the things that are available to, easy access to, like the affordable and accessible microcontrollers, the rise of makerspaces, 3D printing, the communication protocols that we all have today, and stores that you can buy parts from online, like SparkFun, Adafruit, and DigiKey, and then on the other end, the things that we can plug our stuff into, like the Continuum and Eaganmatrix and Linsterman, Rolling Seaboard, and all those things that,
Do you know about McMaster?
No.
You know about it.
yeah, I'm aware.
It's all mechanical parts. It's every screw in the
Oh,
world.
for a site.
Yeah, in
website, yeah.
Fusion
Okay.
360, they
Not
have
for
components for
university.
Oh, right, yeah, I think that's on the, when you go in there and you,
Yeah, all
Yeah.
CAD has that. All native.
And do you know about Tangio?
no.
Tangio.co, they're a company that makes FSRs. They have one-dimensional, they have two-dimensional, longitudinal ones where you have position and pressure. They have three-dimensional XYZ trackpads, and they even have a multi-touch, it's an FSR array, and they have example software for it too. So it's Tangio.co, and they're in Canada, and they're actually the company that prints my custom sensor at Oral Instrument.
Okay, what I'm gonna do is, if these videos get saved and preserved, I'm gonna go back and rewatch this whole thing and make sure that I catch everything.
No, just actually, what you can do, I'll give you
Yeah.
my email address.
Yeah.
If you go to my site, rogerlindesign.com, any email you find on that site or phone number goes directly to me
Yeah.
because there's nobody else there.
Yeah.
So,
It also helps to have, this really ties back to our original point to it, our original reason for doing this presentation. It helps to have an inspiration behind this, and it's really the Eaganmatrix and the Continuum that made this happen, and it's especially the ContinuuCon. So
Yeah.
the message out there is like, get out of your box,
Mhm.
find a couple friends, and look, there's plenty of resources, and there's no excuse to not make what you want to make.
Yeah.
Right,
Mhm.
so for the half of you that aren't already making something.
And I had written up a little essay that's a little bit too long, but you're gonna run into a whole bunch of brick walls along the way, and just every brick wall is a learning experience, and just crash into it with joy.
Crash with joy.
Yes.